Okay, here is the key for all this trig final stuff. We'll start with the additional problems because this is the one I have on top. So we want to solve this trig equation. Move the 2 over, so 2 sine of 3x will be -1. Divide by 2, sine of 3x is -1/2. Okay, so we got to solve this. We have to go around the unit circle 3 times. So where does sine equal -1/2? We know all students take calculus, so we want quadrants 3 and 4. Sine is a half at 30 degrees, so that both of these are 30-degree reference angles. So this is pi plus another pi over 6. So that would be 6 pi over 6, 7 pi over 6, and 11 pi over 6, or the first time around. Now I have to go around again, so I have to add 2 pi to each of these, which is 12 pi over 6. So adding 12 there would be 19 pi over 6. Another 12 here would be 23 pi over 6. That's the second time around. And then one more. Adding another 12, what is that? 31 pi over 6. Adding another 12 here would be 35 pi over 6. Okay, are those right? 24, 25. Okay, so then we get x equals, and just list all these out. Order doesn't really matter here. 31 pi over 6, 11 pi over 6, 23 pi over 6, 35 pi over 6, plus 2k pi. They're all of the infinite number of solutions. Okay, here we want to solve this. The best thing to do is probably use the double angle formula and convert that sine of 2x to sine twice sine x cosine x minus cosine x equals 0. Factor out that common factor, cosine x. If you have a non-linear trig equation, I guarantee you're going to be factoring. 1 equals 0. So I want cosine x equals 0. Cosine equals 0 at pi over 2 and 3 pi over 2. And I want sine x equals a half. That's at 30 degrees and 150 degrees, or pi over 6 and 5 pi over 6. So we get x equals pi over 2, 3 pi over 2, 5 pi over 6, pi over 6. Probably should have written those in the other order, but it doesn't matter. 2k pi. Don't forget the plus 2k pi. Okay, x-intercepts. We'll find x-intercepts by setting our function equal to 0. Probably going to be easiest to convert this tangent to sine over cosine. Again, we're going to be factoring. We need a 0 on one side, or factoring is a waste of time. We have the 0, so sine of x. We get 1 over cosine minus 1. So we want sine of x equals 0, or this should be obvious that that's cosine equals 1. If you don't believe that, go through the algebra. But that's cosine equals 1. So where does sine equal 0? At 0 and pi. Where does cosine equal 1? At 0. So we get 0 and pi plus 2k pi. It's just an ugly plus. It's a plus sign. Okay, x-intercepts here. That's cosine of x plus a half equals 0. So cosine equals -1/2. So all students take calculus. That would be quadrants 2 and 3. Cosine equals a half at a 60-degree angle. So these are two 60-degree reference angles. That's pi over 3. So that would be a 2 pi over 3. Here's 3 pi over 3. That would be 4 pi over 3. So x is pi over 3, 4 pi over 3, plus 2k pi. Okay, next page. We want to rewrite this in Cartesian coordinates. Trick we want to use here, multiply both sides by r. Just basically add in an extra r on each side. R squared is x squared plus y squared. R sine theta is y. We're done. That's it. Okay, we got our flagpole here. Here's the sun over here. Angle of elevations here measured from the ground, 32 degrees. This side is 15, call this x. So then tangent of 32 degrees will be x over 15. X is 15 tangent of 32 degrees, whatever that is. I'm not getting out the calculator right now. I'm going to have to later. I guess I'll get it out. Hold on. Let me pause. That's about 9.4. And what are our units? We have to have units. Feet. Okay, we want to verify this identity. We write down one side exactly the way it looks. Don't change anything. I just chose the left side at random. In this particular case, it doesn't really matter. Put an equal sign. And then change something minor. Remember with these, when you have a 1 minus sign, a 1 plus cosine, anything like that, the trick is to multiply top and bottom by the conjugate of that factor. So 1 plus sine x, top and bottom. Okay, you might think you want to distribute here, but you actually don't. I mean, I can see in the end I need a 1 plus sign, so if I distribute, I'm going to have to factor again later. So I'm going to leave the top factored. On the bottom, it's just difference of squares formula. I get a 1, plus sign, minus sign, those cancel, minus a sine squared. So that's just 1 minus sine squared x. But 1 minus sine squared is cosine squared. And then one of the cosines cancels, and I get exactly what I was trying to get. Hey, look, that's what I was after, right there. And then I say, I'm done. Okay, next page. No calculators here, exact values. I want arc sine of -2/5. Okay, so first thing we do is give this a name. Let's call it theta. So theta is arc sine of -2/5. So taking the sine of both sides, we'll get sine of theta is -2/5. So we got to figure out what quadrant we're in. Well, arc sine spits out angles in quadrants 1 or 4. Since it's negative, it must be quadrant 4. Here's my angle theta. -2 is opposite. Hypotenuse is 5. Do some Pythagorean. So that'd be 25 minus 4. This would be square root of 21. This whole thing was theta, so tangent of theta would be opposite over adjacent. -2 over root 21. We're done. Okay, cosine of 5 pi over 6. We got to think here. 5 pi over 6 is here in quadrant 2. Arc cosine spits out angles in quadrants 1 or 2. So these will, in fact, just cancel, and we do just get 5 pi over 6. If this were a quadrant 3 or 4 angle, that would not work. It would translate that angle back to 1 or 2. Arc sine uses 1 and 4. Arc tangent also uses 1 and 4. Okay, we want the angle between these vectors. We got to calculate a few things. V dot W would be multiply the x's, multiply the y's, 48. I think that's 33. There's our dot product. Magnitude of V would be 5. Magnitude of W would be 13. So cosine of the angle between them is V dot W divided by the product of the magnitudes. So that's 33 divided by 5 times 13. So theta is inverse cosine, and we can trust the calculator here. Okay, so pause, type that in. And I got 59.5, I think it was. 59 something. 59.5 degrees. Okay, sine of 2x. Double angle formula. Sine, twice sine x, cosine x. So we're in quadrant 2. Pythagorean to get that third side. That is a negative. You got to get that from the picture. Then sine of x we already knew was 4/5. Cosine of x would be negative 3/5. Just multiply across, we get 6 times 3, 8 times 3, negative 24 over 25. Okay, we got a boat traveling in still water, going straight across a river. Excuse me, my boat's going that way. Let's call that, I don't know, B. And let's say that's 10, 0. It's going straight along the x-axis. I've introduced a coordinate system here. Let's say the current, C, is going straight up. So my current, I guess I can write it here, would be 0, 4. Yep, I like it. Okay, so here's C. Then the net, the velocity, is just C plus B. Add those together. So we just get 10, 4. Add the x's, add the y's. We want the speed. Speed is the magnitude of velocity. That's square root of 100 plus 16, 116, whatever that is. And then the angle, theta, arctangent of y over x. So, let me draw it here. This is what my net velocity looks like. This is the angle I just found. This side was 4, this side was 10. So whatever that angle is, that'll be the angle from straight across the river toward downstream. You can type those in your calculator. Okay, that's miles per hour. Here, this is from straight across. Okay, we got Dave walking around a circular lake. This is a 50-degree angle. We're told the radius is 0.5. Okay, so S over C is theta over 360. S over 2 times pi times R will be 50 over 360 degrees. Degrees cancel, the zeros cancel. We'll get S is 2 pi times 0.5 times 50 all over 36. Type that in the calculator. And so we get S is about, I got 4.36 kilometers. Is it 4? Let me check that. Wait a minute. No, that's not right. It's 0.436. I knew there was no way it was 4. That was way too big. Okay. We got this plane flying northeast. So this east is this side. Right here, that's a 45-degree angle. It's 300. Wind is blowing this way. It's also a 45-degree reference angle. And it has magnitude 20. Okay, so the plane as a vector, let's draw him separately here. This is the x component. This is the y component. This is 300. That's a 45-degree angle. So the x component will be 300 times cosine of 45 degrees. The y component is 300 sine of 45 degrees. And yeah, we could use root 2 over 2 and all that, but here's if we're going to use the calculator. And these are both 212.13. Okay, so that's my P vector, 212.13, comma, kind of ran out of the room there, 212.13. Okay, the wind vector. He points back this way with a 45-degree angle. Notice his x component is 0. So we do our work and we'll get 14.14. The x component is negative, the y is positive. So we add those together and we get our net velocity vector. 212 minus 14 for the x. Oh my God, it's bothering me. You guys are too lazy to do that. And we get about 25 meters. Okay, we want to prove this identity. Start with the more complicated side. Write it down exactly the way it looks. Put an equal sign and make some minor changes. I'm going to rewrite that tangent as sine over cosine. Oh, I left something out. Minus cosine squared x. Minus cosine squared x. So that was the left side. Do some canceling here. Oh, look, I get sine over sine. That's just 1. I get 1 minus cos squared x. That's sine squared x. I'm done. Okay, we're in quadrant 2. So we're told this side's negative 12. Here's our angle x. This side is 13. This side would be 5, and that's positive. Sine of 2x is twice sine x cosine x. So twice 5 over 13, negative 12 over 13. So that's negative 120 over 169. Okay, period is 2 pi over b. B is 2, so 2 pi over 2 is just pi. Amplitude's the absolute value, this number right there, 2. Phase shift is opposite of c over b, so pi, opposite of negative pi, over 2. Vertical shift is up 1. And yes, you should write up 1. Okay, area of a sector is 1/2 r squared theta if we're in radians. Only if we're in radians, but hey, we're in radians. So that's going to be 1/2 r is 5 squared times pi over 3. I'll throw that in a calculator. And I got about 13.1 square centimeters. Area is always measured in square units. Okay, we want to convert this from radians to degrees. So I do theta in radians over 2 pi equals theta in degrees over 360, or you can do theta over pi is theta in degrees over 180. Either one's fine. I don't know, this one's a little less work. We'll do this one. So we get pi over 7 over pi equals theta in degrees divided by 180. Okay, so the pi's cancel there. I get 180 over 7. Yeah, that's in degrees. Is theta in degrees. That's about 25.7 degrees. Okay, we called this guy theta. So theta is the inverse sine of negative root 2 over 2. So take the sine of both sides. Draw our triangle. Clearly, if I've got a negative, I'm down here in quadrant 4 because it's arc sine. So I've got negative root 2. 2, this side will also be root 2, but positive. I want tangent of theta, so I'll get negative root 2 over root 2, or negative 1. Or you could say, hey, wait a minute, that's a unit circle. That's negative 45 degrees, and tangent of negative 45 degrees is negative 1. Okay, same game here. Call this theta. So theta is arctangent of 10 over 1. So tangent of theta is 10 over 1. Draw a triangle. We're in quadrant 1 here. Opposite over adjacent. This side then will be square root of 101. I want cosine of theta, which would be adjacent over hypotenuse. We're done. Okay, now we're going to solve the triangle. These are fancy ways of saying A and B. Okay, so A, B, C. A is 50 degrees. B is 20 degrees. Side B is 60 meters. Here's side A, side C. Our answer is going to be this table. Okay, I've got these guys. That's 50. That's 20. That makes up 70 degrees. Oh, labeled the wrong one. This one's 20. That's 70, so that makes C 110 degrees. That's something I found, so I'm going to circle it. I'm told B equals 60 meters. Better put the meters there. Okay, so what do I know? I know 3 angles and a side. That's a law of sines problem. I'm going to fill this guy in. That's 110. Okay, so I could say sine of, I don't know, A over little a is sine of B over little b. So A, side A, is going to be B sine A over sine B. Let me type that in a calculator. And I got 134.4 meters. Similarly, for side C, we're going to get B sine C over sine B. And I got 164.8 meters. Okay, we want to find the exact value of cosine of 15. I could use half angle formula. I could use cosine of x over 2 is, look at my sheet here. Oh, I'm on the last problem. Yay! Didn't realize. I could say that is plus or minus square root of 1 plus cosine of 15 degrees over 2. I'm in quadrant 1, so I know I'm going to want the plus. And, sorry, that's not 15 there. That's cosine of square root of 1 plus cosine of 30 over 2. Because I want cosine of 15. Going from here to here, I have to double it. I know cosine of 30 is root 3 over 2, all over 2. Leave it like that. That square root goes all the way to the ground. Or I could do cosine of 45 minus 30, which would be, looking at our formula, that would be cosine 45 cos 30 plus sine 45 sine 30. So that's root 2 over 2, root 3 over 2 plus root 2 over 2, 1/2. That's root 6 over 4 plus root 2 over 4. Either way is fine. Those are equivalent. Okay, that's the end. I've gone through all of them now, but I think when I was recording this that I may have paused in the middle of a couple of pages here. I'm not sure it all got recorded. So if you've watched it all, you can stop watching. I'm going to go back through a couple of these pages again, just in case I was actually paused and not talking about them. Okay, so I'm pretty sure I had all those. I think maybe here, this front page may have been paused. Okay, so I'm going to talk through these again. You've already watched these. If these are in fact here, there's no way for me to check without stopping the video, and then I can't add it back in. So just in case I did mess up, I'm going to go through some of these again. Okay, here on this one, we were converting from Cartesian to polar. So we're using r as square root of the x squared plus the y squared. And then theta is the inverse tangent of the y over the x. We have to check our quadrant. This point lives in quadrant 4, so I can trust the calculator there. That's how I got these numbers. On this one, this point lives in quadrant 1. That's clearly a 45-degree angle because we're over and up the same amount. So just using Pythagorean, this other side is 3 root 2 and a 45-degree angle. Converting to polar converting to Cartesian, we just use calculator. X is r cos of theta, y is r sine of theta. Those are just plug and chug. I did them using unit circle angles. Finding the magnitude of a vector, square root of x squared plus y squared, we get root 13. The vector from one point to another is final minus initial. So 1 minus 2 is the x, 7 minus 3 is the y. Okay. On this page, we need to always draw out the triangle in the appropriate quadrant. That's very important. And label the triangle. Notice that this side is negative. The x values are negative. So we get all of these values. And then this one's pretty straightforward. Just fill out the triangle. Okay. Think if there was an issue, this is where it ended. I think all of these should be good. Okay, that should be all of them.